So we're looking at Lesson 8 in Unit 5. And we're talking about something that has probably become pretty comfortable for you and pretty easy to understand over the years, just because you see this in so many places in life, and that's tables. And so, you can ask your kids if they've seen it anywhere besides math class. Maybe they have, maybe they haven't. But there's some vocabulary with tables that we've become pretty familiar with and pretty comfortable with that we have to remember at their age. They just don't remember these names. These are not easy names to latch on to and know. So that might be one of the places we need to be patient. So some of the vocabulary that we use, first off, is table. And a table is just what you see here. It's a way to organize data. So here, I believe we have maybe a pizza company that's been selling pizzas, and they kept track of how many of each kind they sold. And so we have, first off, our columns. So that's one word that they need to remember is the word column. And, it's a lot of times it's really difficult for kids to remember which one's column, which one's row. So I like to say, if you look at, the really big houses, or you look at the courthouses, things like that, they have those big columns that stand up in front to help hold the roof or the awning up. And so those are called columns there, and they typically will know that. And so columns for us in a table are also the up and down ones, the ones going straight up and down. So here we have our columns. Now, you can always ask when you look at a table, because in your homework you're going to have tables. When you look in the table, just before you even get started, just look at the table and understand it and remind your child what is table, what is row. And so you can ask, what are the columns in this table? And the answer is this column is the cheese column, this column is the supreme column, and this column is the veggie column. And then we have another word called row, and that's those over here. Now, row are going across. Now, you can equate this depending on what you guys do on a regular basis here. If you go to a game, the bleachers are in a row. If you go to the movie theater, you can choose which row you're going to sit at. And when you look at the row is going across. Just like the rows on a table. In church, the pews or rows are going across when you look at them. So the rows are going across, and here our rows are the Saturday, so how many pizzas are bought on Saturday, and the Sunday, how many pizzas are bought on Sunday. So those are the rows. Okay, and then our last word, vocabulary word that we need to talk about is the cell. And that's just that little block in there. What does that cell stand for? And so then again, you might want to just pick one of the numbers and you might want to say, okay, what does this 28 stand for in this cell? What does the cell stand for? And the correct answer would be how many Supreme pizzas they sold on Sunday. They sold 28 Supreme pizzas on Sunday. Okay, so basically, once we get used to the setup this and become comfortable with it, and so if you're struggling on the homework, this is one thing you might want to start doing is just making sure we understand our columns and our rows and our cells and what they stand for. And then once we do that, then what we moved into was doing adding and subtracting problems with these. So they started out by asking questions like, how many cheese pizzas were ordered on Sunday? So they would have to just identify that first. So here's Sunday, and here's cheese. And if we line them up, Sunday and cheese line up at 19. So there was 19 cheese pizzas on Sunday. And then it says how many veggie pizzas were ordered on Saturday. So we line the Saturday up with veggie, and we see that there was 5 veggie pizzas ordered on Saturday. And then comes the real fun stuff. How many Supreme pizzas were ordered altogether? So that's where we have a little bit of math going on here. So we've got Supreme in this column. There was 26 on Saturdays, 28 on Sunday. The question was how many altogether? And so you have to decide, are we adding or subtracting? And hopefully they understand adding and subtracting enough to know that if you want them both together, you're putting them together, we're adding. And so then they need to add 26 plus 28. This will be fun. 26 plus 28. We go through our methods of adding and we get 54. So there was 54, Supreme pizzas. And then how many pizzas were ordered on Sunday? So we want to know, on Sunday we ordered 19 cheese, 28 Supreme, 15 veggie. How many pizzas were ordered altogether? So then they need to add all 3 of those, and that would be 62. Then what we work on, We're so used to being asked these questions in math class, and I'm sure you were too when you were in school. You're asked all kinds of questions. But what we found in our research on teaching math is we can get kids to understand things better if they come up with questions also, because now all of a sudden they have to understand where the numbers are coming from. They have to understand, why is it adding? I have to come up with something that's putting things together, or why is it subtracting? I have to come up with something taking apart. And so by them actually constructing their own question, we're really helping them understand it better. So, you know, my child has struggled with this herself, coming up with a question on her own. And this was probably, when we first got this series, the biggest frustration at my house was getting her to come up with her own problems. Part of that problem is she wanted to be the most inventive, creative person in the world coming up with a problem. But ultimately, you know, it's just coming up and having an imagination, but it doesn't have to be a horrible imagination. I mean, just do the problem. If you guys could just talk it out and then help them write it down, whatever you have to do to get them to come up with a problem. But ultimately, it really is a very useful thing to do, and something that if they can get used to doing that, it makes life so much easier for them in understanding what they're doing. So, let's see here. Coming up with your own question, you'll see that. Okay, here it is. Sorry. Coming up with your own questions, whether they're adding or subtracting. I believe in your homework, it asked for, sorry, I'm paging through trying to find the homework. Write an addition question and one subtraction question based on the table above, and then find the answers. So I have a different table, but if I was doing that, I would just probably, figure out, how do you do subtraction? Oh, how many more cheese pizzas were sold on Saturday than on Sunday, right? So you might have to give them an example so that they can kind of make them, do something similar to what you're doing. But don't give them the answer. Let them come up with their own, but you could give them an idea of what it would sound like and what it would look like. They did do it in class, but we all know how easy we can forget that kind of stuff. Okay. The next thing that they had them do in class today, you don't have to do it in homework, but I just want to mention it, is they did have them move the table over a little bit, and they had them do totals. Okay, so they said, okay, how many total did they sell on Sunday? Figure that out. And that's actually helping them come up with an addition problem. And then how many total did they sell on Sunday? That's another addition problem. Then they also did a total down here. If I put something here, I'm finding the total number of cheese, or the total number of supreme, the total number of veggie. So, we added onto the table and we made totals so that they get the idea of how you can also have another column or another row that's not necessarily another day, but a total of all of those things. Okay, and why, after that, we looked to finding patterns. And this is big for me as a high school teacher. The kids have already started looking for patterns. How are we going from one week to the next? And so if I look here, this looks like it's getting smaller, so I'm probably subtracting. So I figure out, how much is 285 away from 300. Sorry, that's a 5. So we find it's 15. So we subtracted 15. So then we say maybe that's the rule, subtract 15. So then we try it. We subtract another 15, and we get 270. And we subtract another 15, and we get 255. And that actually worked out. So it's probably that we subtract 15 as our rule. So they're coming up with these things. And see, when they get to algebra, I know how much we all love that. When they get to algebra, they have to come up with more than just subtract 15. They have to put it in an algebraic statement with x's and y's and all that good stuff. And so instead of making them sit there and just start trying to find these patterns, they've already practiced it by doing some of these things in these tables. Another pattern that they might be looking for is maybe, how do you get from the input to the output? What are you doing every single time to get from the input to the output? And you might remember these tables from your older years. And so if you look at each one of these, if you try it out, it looks like it's plus 20. And so I try it out, add 20, yep, add 20, yep, add 20, yep, add 20, add 20. They all work, so my rule is to add 20. Okay, I don't think that's also on your homework, luckily, but I just want to make sure you knew kind of what they looked at in class today. So on your homework, you're looking at the stuff we spent the most time on, the table at the beginning, and how to answer those questions by adding or subtracting, then coming up with your own. All right, good luck.